Okay, in this video we will cover critical values. Again, I hope you already have your PDF printed so you can follow along. This is just another method of doing a hypothesis test. There are two methods, p-value and critical value. The p-value is the method we did in the last video where you compare your p-value to your alpha and make a decision whether to reject or fail to reject your null. In this one, we're going to use our critical values to make that determination. Okay. So starting out, again, we have information such as they tell us in this one the claim is mu equals 30, alpha is 0.04, sigma is 3.09, x bar is 28.8, and n equals 71. A few things to really focus on. This problem's easier because they tell us everything, but be sure when you're given a reading problem, you really read it. Make sure you know if you're dealing with sample data or population. Do they tell you this, the mean from a sample? If so, that, of course, is x bar. And then again, sigma is standard deviation from a population. You have to really carefully read these when you're given a word problem. This one, they were nice. We don't have to think too much about it. Now, I start out by writing my hypothesis. They tell me my claim was mu equals 30. Since that has an equal sign, that is my null. The alternative is its opposite. Okay, I always write down everything I know. They tell me that was the claim, so I write down claim. Here, that's my alternative again, so they're complete opposites, complements, and since it's not equal to, that's two-tailed. In other words, that takes into account greater than and less than, two sides, two-tailed. I always write that down. Next, we're going to calculate our test statistic. We're going to do that in the calculator. So in the calculator, I'm going to go to Stat, Test, and Z-test, and then I input all my data. Make sure Stats is highlighted. I changed calculators and didn't realize I had data highlighted, and it gave me all kinds of weird questions. So I realized real quick that I had forgotten to change that. So be sure you always double check it. It's easy to miss. You can see I've already entered our information. I entered the mu, sigma, x bar, the sample size n. Sometimes that may say sample size instead of n. You have to know what that represents. And this line, the not equal to, less than, or greater than, that always comes from the alternative. Don't get confused. I know there's a little sub-zero. That's just talking about mu. This line always comes from your alternative hypothesis. So ours was not equal to, so that's what I input. Now I'll scroll down one. Whoops, I thought I was on a different line. Scroll down several. Hit calculate. Gives me all kinds of good information. Mostly it tells me that z equals negative 3.27. It also gives me the p-value. We're not using that this time, but it's always there. Okay, negative 3.27 is my z test statistic. Okay, now we need to find the critical values. Here is the most important thing you can know. Kind of scroll out so hopefully you can see the page. Hopefully you can enlarge it on your screen. Critical values are determined by alpha. Okay, they are determined by alpha. Alpha is basically our maximum allowable error. Okay, and we're going to use it to determine our critical values. And then our critical values determine the boundary of our region of rejection. Okay, so again, we use alpha to find our critical values because that defines our region of rejection. You can see I've already got it drawn out, so I want to kind of point some things out, and then I'll show you where I found the critical values. Basically, that boundary that I found before I found the critical values, which again I'll show you in a minute how I found that, beyond those numbers, we reject H naught. So beyond, meaning greater than the positive, less than the negative, we reject our null. In the middle, we fail to reject our null. What we do is we take our test statistic and we determine where does it lie. This is a number line. Where is it? Well, negative 3.27 would be to the left of that critical value. It's in a reject region. Okay, so that's the overall concept, but let's go back and find out how did I find the critical values. Okay, well, I used my calculator. I used alpha, which is area. Alpha 0.04 is area. It's a two-tailed test. So our reject area, so basically area, alpha is your reject area. It's the area that you're going to reject if your test statistic falls in that area. Okay. So since it's a two-tailed test, we have to divide that reject area into two tails. So that 0.04 gets divided by 2, and there's 0.02 in the left side and 0.02 in the right side. Okay, just kind of giving the whole picture here. Our alpha was 0.04, that's our reject area. We divide it by 2 because it's divided evenly between the two tails, and we have 0.02 and 0.02 area. Area is inside, okay? If we know the area, we can find the corresponding z value. That's from our last test. How do we do that? We use second bar's inverse norm, enter the area to the left of z, your mu, and your sigma, okay? So I'm going to pull on my calculator to focus on that for a minute. Again, we're given area. Once you know area, you can find your z value. To me, since you have to do area to the left, this one's the easiest one. My area to the left of that value is 0.02. So if I know my area, I go to second bar's inverse norm, enter the area to the left. So let's do that. So second bar's inverse norm. Remember, area to the left was 0.02, okay? And then comma 0, comma 1. Again, this goes back to the last section. Why? Because my mu for my z is always 0 and my sigma is always 1. We all have that memorized by now, I hope. Gives me negative 2.05. Okay, make sure you get that, negative 2.05. Now I'm going to scoot over here. That's the number I wrote here. Based on symmetry, if the area to the left of this point on the z-axis is negative 2.05, the area to the right of 0.02 over here is positive 2.05. They are complements. I find the one over here first because it's the easiest, because the calculator wants area to the left and I don't have to do any work to find that. Okay, so now I have my critical values. Now what I need to do is I need to look back at my test statistic. Does my test statistic fall in the reject region based on these boundaries that were defined by alpha? Okay, again, alpha was divided by 2 because I had a two-tailed test. That area defines my reject region. I need to know the boundary so I can compare those two values. I find that by doing inverse norm, entering my area to the left. That gives me my critical value. I know the other one's its opposite. And here, look at my test statistic. It actually is more extreme. It falls to the left. It's more negative than this boundary of the critical value. Therefore, it falls in my reject region. Okay? So, that tells me, so you can kind of see it all here, I'm going to reject my null. Okay? So basically, if I reject my null, looking back up to the top, the null was my claim. So I'm rejecting my claim. Okay? So I fell in the reject region. So from step 1, that was my null. We just determined to reject it. So we're rejecting the null hypothesis. Okay? So basically, since we reject H0, which was the claim, we do not support the claim. We reject it. They kind of use weird words in MyLabs Plus, but if we reject something, we're not supporting it. Okay? And since H0 is what we're rejecting and it was the claim, we do not support the claim.